buildings are antiques, this antique.
Well, certainly the building is a piece of our history.
Regardless of its shape and form, it's a wow building.
Berkshire Athenaeum, I think, is a wonderful building. It anchors that side of Park Square.
I think everybody just loves the building. They love coming in here and doing the work. And it's very admired, the architecture, the history of it.
Buildings like this are a big part of downtowns, of preserving the history of the area.
The building itself from the outside is so beautifully preserved and so exquisite in its design, and I felt that the use of it was good to preserve a building of that nature and that stature.
I had heard that there were issues with the building itself, and it always made me feel very sad because I always thought that it was just one of the most beautiful buildings in Pittsfield. Architecturally, it was pretty interesting, and it had a lot of character. Strength and character is what I felt when I walked in.
I think the old Berkshire Athenaeum is particularly unique. It certainly is to Pittsfield, and a lot of New England towns, cities have prominent structures like this from the past. A lot have been lost, and a lot, unlike this old Berkshire Athenaeum, I feel have been changed, dramatically.
It gives you a different sense about your community when you're surrounded by buildings that speak to the history of the community and the history of the town.
So when we see a building like this is really special, and people will travel to Pittsfield to see it.
The first time in many years that I came through Pittsfield, I drove by that building, and the old Athenaeum building really stood out to me as just being unique.
They don't build buildings like this anymore. The size of it, the scale, the stained glass fenestration, the arched opening, the fact that you've got this symmetrical pattern of these two gables left and right, then you've got this, what had originally been an open skylight way up, that then with the glass four-foot light in. Not even knowing that, because not being inside the building, if you're a passerby, you go, wow, that's a massive effort. And our history leads us to this time of all the stonework that's been done and was done in Boston, and this is Western Massachusetts' example of it.
And yet it is the stonework that presented structural issues that required attention. For close to 2 years, the Commonwealth of Massachusetts has undertaken a highly complex operation to save the old Berkshire Athenaeum in Pittsfield, Massachusetts. This unique model of Victorian Gothic architecture in New England stands apart on Park Square, in the center of the city. Originally built in 1876, this was Pittsfield's library for almost 100 years, before the county and then the state took over ownership and turned it into a courthouse and registry of deeds. When a new library was finally built, a Berkshire County Commissioner named James Bowes led the effort to save the building. He died before seeing the completed courthouse, but in his honor it was renamed the Bowes Building. In 2010, the state determined more repairs were needed for life safety reasons. Preservation history is replete with successes and failures. The old Berkshire Athenaeum qualifies as a success story. This building conveys the story of a town and its people from the late 1800s, with their aspirations and grand designs for their future, but proudly proclaiming how far they had come. Its history traces Pittsfield through rapid growth and then into its decline from the loss of manufacturing, but the building still stands and contributes to the fabric of the city in its efforts for economic revitalization. More than that, it's a prompt for individual memories of residents who made this one of the busiest libraries in the state, gathering there after school and on the weekends to learn and explore, for amusement and socializing. Historic preservation is not just about buildings, it's about people, it's about communities. Here is the record of remarkable efforts by many people: government officials, architects, masons, electricians, contractors, accountants, craftsmen who came together to solve, in complex and even heroic ways, this building's flaws in order to ensure that it will continue to serve the city, its residents, and its visitors. And it was one such visitor in 2009 who first detected problems in the building.
We were awarded a house doctor contract with the state through the designer selection process called the DSP. The courts selected us from a list, I guess, of designers. Well, we were working on the Superior Court building in 2009, and while we were working on it, occasionally we'd notice when we were up on the roof and you'd walk by a chimney or something that was vertical, and you'd line up. I do that anyway with other buildings. I line up and I see how, isn't it interesting how vertical is vertical, things all line up, but that one didn't. It wasn't, I think it was leaning, no, it's leaning back. So the top appeared to me to be several inches south of the bottom of the wall. And I kept looking at it thinking it maybe is some kind of an illusion, but after a while I began convinced that that wall wasn't straight, and it was frightening. I mean, I really thought for a minute the first few times I walked through the door that I better walk fast before that bulge came out.
It started actually not as life safety per se. It started as a repair to the exterior facade that was necessary. And upon investigation, it was seen that it was more than just simple repair in certain areas of the stonework, which led to the more emergency definition of what the situation became, because it was something that had been ongoing, and it was evident that the fix wasn't going to be kicking the stone down the road. It was going to.
So when we first started studying the building, one of the things that was immediately obvious is that the front wall of the building was moving. You could see a lot of cracking. There were actual large bulges in some of the stone units where they were displaced outward from the plane of the wall.
And they had us use the mason that was working on the courthouse to take out a couple of stones a couple of years ago to see what was there. We went up and we took a stone out where the bulge was, and I reached in and I found that there was 5 or 6 inches between the back of the stone and the backup wall. And further, I could see indentations in the backup wall that showed that the stone had once been back up against the backup wall. It wasn't where it was supposed to be. And the mortar inside was more like damp beach sand. So that was frightening.
So that there is backup masonry, and then there is the face masonry that you see, and in between them is basically a bed of mortar. So over time, things move a little bit, that mortar gets displaced a little bit loose, and there also then are some issues with problems with flashing and water infiltration. So if there are any issues with the roof and the water can get in behind that front plane of masonry, it starts to wash out that mortar bed, and you lose that bond between those two planes of masonry.
It seems like this one's been more brewing, that they've noticed that there's been problems, that when people look up at the building and they see cracks, they say, I think, is that crack bigger than it was last time, or how much movement is actually occurring out there? And it sounds like there were some really good studies done maybe 2 or 3 years ago where they come out and did 3D imaging of the whole north facade. And they were able to build some computer models of that and figure out that certain areas of the facade had up to 6 inches of displacement, which is a ton. So you're talking about stones leaning more than 6 inches away from the building they should be. The reason why it's still partially safe is because it's all locked together. So you've got 6 inches of movement in one spot, and it tapers back 5, 4, 3, 2, 1 over a long period. Those stones are in place, but at some point, some sort of event, you've created an unsafe condition in a public building and led to a project of this magnitude.
You know, we had some plaster falling and some cracks, you know, from the shifting of the front of the building. And back in the 80s, they noticed this was happening. So they did some supportive metal bands that seemed to work temporarily. And then they noticed a little bit of the bowing happening and some shifting and larger cracks and more of the ceiling coming down. And the stained glass windows in the front were shifting and breaking. Parts of the stained glass windows were breaking out.
Maybe now it's a little more exponential because of climate and pollution and everything else, but also because of the failure of the eventual failure, seemingly, of the lack of buttress support for these larger openings that were cut into the facade. The south facade doesn't seem to have the same issue because they put the addition on, so that's one large buttress that goes against it. But here on the north facade, there's only a buttress that projects out 8 inches, and it's fairly thin on each side of the gables.
What we realize now is that at that time, 1876 or so, this architect did not pay any attention to horizontal forces. When they put in this huge stained glass window, 2 of them on the front, on the north facade, they were too big for the wall. They didn't leave enough wall to resist the horizontal forces of the arch that pushes. And so the wall was spreading out, and that's how the water got in, and that was the... But it took a long time. It took like 100 years for this to happen.
It did take a long time for the building to reach the condition found in 2009. But over its almost 140-year history, many attempts have been made to correct its structural flaws. Due to a design intended more as an ornate monument to replicate the grand palaces of Venice or Victorian England than to serve its function as a library. Why the first donors and the architect chose form over function says a lot about the region and the nation in the years following the Civil War.
Buildings tell a story, exactly, in their pieces and parts. And then not only do I have the interest in the story they tell structurally, but then it opens up the whole world of what went on and what transpired in these buildings.
Pittsfield Library Association, that was sort of the beginnings of the Athenaeum. But then there was a recognition among citizens in after the Civil War in the 1800s, that it was important to have a library for the people of Pittsfield. And so many influential members of the community and those who had left the community and come back, such as Thomas Allen, wanted to provide for such a building and such a collection in Berkshire County. The first Thomas Allen here in Pittsfield was the Reverend Thomas Allen, who was the minister of the Congregational Church from the 1760s on up through the Revolution. And then he had many children. And this Thomas, who was the benefactor of the Athenaeum, was a descendant and went west and made his fortune. His father couldn't give him too much, and so he made his fortune and then came back and wanted to, reclaim some of the land in Pittsfield that had been the Allen family land, and wanted to also give back to the community.
Thomas Allen was a man ahead of his time. He married a young woman from Missouri and followed her there, where he made his fortune on railroads by the 1850s, pushing the lines west decades before the continental connections were laid and before the railroad tycoons became known as robber barons. Allen could lay claim as the first cottager in the Berkshires, since his Eagle's Nest, built of stone on Park Square in 1858, was the first of many grand estates in the county. Cottages for the likes of the Carnegies, Vanderbilts, Westinghouses, and others, but only later, in the 1890s. The first militia formed in Berkshire County before fighting broke out in the Civil War was named the Allen Guard after his generous donation. Allen had made a gift of $50,000 to his hometown and persuaded his cousin Phineas to bequeath a similar amount.
Influential members of the community, and those who had left the community and come back, such as Thomas Allen, wanted to provide for such a building and such a collection in Berkshire County. And so they pooled their resources and managed to get the land and hire an architect and build the Athenaeum.
The architect who Thomas Allen selected was William Appleton Potter, who had apprenticed with his brother and had only a handful of buildings to his name in 1874, one of which, though, was a university library and another a church in nearby Springfield, Massachusetts.
Well, I also read that he was very well connected socially, so they referred to him as kind of the favorite architect for the upper class at the time.
It was through these connections that Potter became known to Thomas Allen. Potter's grandfather was the long-serving president of Union College in upstate New York. His daughter married a young student, Alonzo Potter. Alonzo went on to serve as vice president to his father-in-law at Union College. One of the students at that time was young Thomas Allen, who was forced to drop out as he could not afford the fees. On this small campus, Thomas must have known the vice president and his family of 10 children, 9 of whom were boys. Young William was the 9th child, but by the age of 3, his family had moved to Philadelphia when his father was elected a bishop in the Episcopal Church. William grew up in a setting steeped in learning, religious values, and achievement. He followed his brothers and sister to the finest schools and to vacations through Europe. The accomplished family would eventually claim a congressman, Civil War general, bishop, president of Hobart College, musician, and 2 architects. William's sister married a sculptor, Launt Thompson, who was developing a broad reputation for his art. His design for a Civil War sculpture was selected for a memorial in Pittsfield that was dedicated in 1872 at the same time that plans for a new library across Park Square were underway. One of the donors tapped to contribute to the fund for the monument was Thomas Allen. Allen undoubtedly was aware of other designs by Potter in Massachusetts, New York, and New Jersey.
Church in Springfield of the same architect. And of course there we were just blown away with how similar the construction and the details were. Amazing. So when I heard about this architect, I talked to a historian who found out there were a lot of his buildings at Princeton.
Here at Princeton we have 4 buildings that were designed by William Potter, and there had been 2 additional ones, but they've been either lost to fire or razed for a dormitory complex or a dining hall and dormitory complex. I think Potter was unacademic. In fact, he was classically trained. He spent time in Europe. Potter was recommended for this particular building by a professor here at the university, professor of science and revealed religion. So it's one of those sort of odd combinations. But at any rate, he was also supported by a few of the trustees, 2 of them named Green, and this is the Chancellor Green building that we're in. So the major donor was one of his supporters.
And Potter's buildings at Princeton have also had their own structural challenges.
In Alexander Hall, we had seen some sagging, I would say, of the roof structure, which was pushing the exterior walls of the main chamber out a bit. A circular brace was installed around the entire auditorium, tying back to exterior walls, I believe, to reinforce the structure that was carrying the main roof. The brace was put inside the auditorium, on the interior of the main auditorium walls. This building itself has been the subject of some structural review. The building, the roof was substantially redone in, let's say, 2003 or thereabouts. And at the time, I think there was concern that it was a very delicate structure. And I think it was designed to look delicate, but I think it also is somewhat delicate. So structural engineers looked at it. I think they determined that it was okay, but that we should be keeping an eye on it. And for a number of years after that, one of the people I work with was assigned the yearly duty of coming here into the rotunda and with binoculars looking up at connections on the trusses that are up there.
It was likely just this kind of elegant design that appealed to Thomas Allen. He seemed to be looking for a monument as his legacy to a town that had recently become the county seat and a major manufacturing center in western Massachusetts.
An architect in the 1800s might rely heavily on not necessarily a mason, but a master builder. I think the architects of the time trusted the builders to make things stand up. Well, a lot of the times there actually were connections where today we see walls that, you know, have a 4-inch or a 6-inch stone face on them that are tied into either concrete or another form of masonry, brick or block, by metal ties. Those walls typically had header courses that tied them together with the next, you know, if it was brick and if the wall was 24 inches thick, you might have 6 lies of brick, and they would be tied together in one form or another with headers. And the same really with stone buildings like this. They would you know, have a stone that might be 12 by 18 inches or whatever for typical coursing on the face. But every so often you're going to see a 12 by 12 or whatever that's turned the other way and tied into the wall behind it.
And so Potter drew the barest of designs, which the Berkshire Athenaeum still has in its archives. He turned the work over to builders in Pittsfield who went near and far to get the materials needed.
New England dried up a lot of their stone with structures like this, city halls, town halls, libraries, and ate through the local quarries. But that was the way they did it back then. Quarry within 100 miles, use horses and get it to the site, build a local stone.
This Great Barrington Bluestone, which is actually a schist, but it's known as Great Barrington Bluestone, is not quarried anymore. The East Longmeadow stone is still very available. There are many, many buildings that are built out of it.
You know, the granite that came from Berkshire County and the red stone that came from out in the Midwest that Thomas Allen had brought in.
It took less than 2 years to build the Berkshire Athenaeum. And so, on September 23, 1876, Thomas Allen took the podium in front of the library at its formal dedication. His words revealed his faith in the benefits of a public library. This country is to be saved, if at all, he said, by the cultivation of patriotism and the diffusion of intelligence. He may have had on his mind the country's centennial celebration just 2 months prior. His reference to saving the country, though, may have been prompted by the seared memories of the Civil War. He may have been looking at the Civil War Memorial across Park Square. He may have been thinking as well that his contribution to the library would save his hometown, with its growing population, fed by the influx of a large number of migrants moving to the town to work in many of its textile and paper factories. By the time the library opened, not only were 2/3 of the town residents born elsewhere, but fully 1/4 were foreign-born.
Purposefully a library.
It was also a museum. The library and the museum were one until the 1930s. And so there were many benefactors and many donors who donated artwork and sculpture and things of all kinds. That we have the old accession books from the beginnings of the library and all of the things that were coming into the library and museum in addition to books. And so it was a real focal point for almost a century, well, actually over a century.
When Mr. Crane put his collection of statues there in the first efforts to create a museum in Pittsfield, it was ideal because everything had a natural access to light. Everything, all the beauty was exposable.
They filled the building up so quickly. The building, by the 20 years after it opened, was full.
It was full because of the growing population of the town, which was incorporated as a city in 1891. Within 3 years after the library's dedication, over 3,000 residents were library card holders, accounting for a circulation of over 25,000 books. William Plunkett, one of the original trustees, admitted to frustration and embarrassment by the inadequate accommodations. So plans were made for an addition that was completed in 1897. The new wing extended the depth of the main building another 80 feet with a width the same size as the original building. The main entrance lobby now moves straight to a waiting area and front desk, and then into the addition, a church-like space for the stacks and tables, which was open to the roof and supported by prominent, exposed, quartered oak trusses and paneling.
And they started to talk about separating out and building a museum to house the artifacts and the statues and the paintings and all those kinds of things. So then it relieved it a little bit when they opened the museum and separated the collections. But it still continued, you know, as Pittsfield grew, because our population in the later 1800s and the beginning of the 1900s, with the growth of population through immigration.
Coming to Pittsfield for work in the mills and factories, residents placed great demands on the library. Throughout the 20th century, this was one of the busiest in the state. Its many patrons came for the books and the knowledge, but the majesty of the building created a special aura that Pittsfield's residents remember with fondness. This was a community center that drew in people from all walks of life.
I think I just remember as a young person, there was kind of a mystery about the building. It was, you know, sort of with the arching ceilings and then all the little nooks and crannies on the sides, because at that point in time the books were mostly in the alcoves. The center, which had at one point been where the books were, had become the reading room, and the little alcoves along the sides were book storage. So I remember going up and down the aisles looking for fiction that I wanted to read. So I spent several hours every afternoon pretty much at the library. And it was very different than the library that we know now, because it was much more the hush-hush, you know, be quiet kind of place, and yet it was a very busy place. So you were sort of tiptoeing around a lot of the time.
Every day after school, I would walk to the library, and I remember walking up the steps. I remember entering the building and just feeling at home. I felt so comfortable, and I think part of it had to do with as you walked in, I mean, the architecture was just so beautiful there. There were the wooden desks, there was the librarian's desk, there was the grand stairway. Everything was just so pretty.
So it gives you really a flavor. This was the public catalog in the early 60s. It shows you so many people are there just in that one little space using that part of the catalog. It shows you how people were dressed and gives you a flavor, the lamps on the tables and things like that, of what the library looked like.
Miss Gamble, when I was at that age, ran the children's department, or at least that's what they called it. And it was upstairs on the second floor, I remember, going up there. And there was always a great amount of kids would show up. Of course, again, it was during the Depression era, and kids didn't buy books, but we certainly borrowed a lot of books from the library.
You know, as a child, I used to like to go and lean over the railing and look down, and you could see the people at the long tables in the main room there, reading and doing their research and so forth. And that, you know, that was pretty exciting to be able to look down.
So it became congested, and it also had structural issues that were going on. So those two things, probably other factors, combined to make the people think, well, the best thing is to build a more modern library, but it took a long time for that to happen.
In the years before the Second World War, the library's leadership began to appeal for a new building. Every year in the 1950s, their annual reports carried complaints about the problems and became more and more vocal in their demands for a new library. They paid for engineering reports and architectural plans and sought funds from both private donors and public sources. Finally, in 1973, Pittsfield City Council approved funding for a new library, just 1 block away from the Athenaeum. It opened just 2 years later, leaving unanswered the question of what to do with the old building.
We looked at the old reports that had been done for various agencies when it was owned by the city 50 years ago, and they were mentioning how dire the need was to make this repair.
But even after that happened and the building was sitting vacant for a while on Park Square, there was a lot of uproar whenever it looked like it might be demolished.
I remember coming back home and seeing that it was closed, and it was an emotional feeling, because I really felt that was home to me. So I was disappointed when it did close.
Everybody had, I don't know what you'd call it, a fever to tear down. That's when West Street started to get demolished, and they tore down all those interesting old buildings for urban renewal, quote unquote. And I think that got involved with it a little bit.
A lot of people look back at our old train station. Also, doesn't receive as much press, but the old Wendell Hotel that was, you know, on Park Square.
You mean when they built the new Athenaeum, there was talk of getting rid of it, and so the state picked it up. And generally when the state picks something up, it's because it's got a bunch of liabilities that the private sector couldn't deal with.
Through the advocacy of the County Commissioner James Bowes and others, the city transferred ownership of the building, which became a county courthouse and registry of deeds. Major repairs were needed, however.
The steel bands that were put in the 70s, really as I'll say a Band-Aid approach to let's stop the movement. You know, we're not going to fix it, we're not correcting it, but we want to try and stop it. So they did a series of metal outside the building and connected it to some metal bands inside the building. So it was an inside-outside connected with a metal fastener to really try and lock those in place so that any movement that was happening would kind of stop.
What was really keeping this building together was very minimal. Our job was to build a frame inside of structural steel, starting in the basement, and putting individual columns, because the length would have been too much to physically install, up all in key areas, corners and specified distances around the interior of the building, and then to drill through the walls and go around the outside with a crane and put the outside band on the bolts. And then there were also tie rods at another level, which I think were really key, because we were to set them and just tighten enough, not try to draw anything back in, but the effort was to keep the masonry in place in the condition it was at the time.
Even these repairs could not prevent further bulging. This time, though, in 2010, there was no debate on whether or not to save the building.
No, it didn't come up, the possibility of tearing it down. No. I think that's the way the state's set up. The office that we're working for, DCAM, their job is to take care of and maintain state property, not to tear it down.
and so DCAM began the extended process to make the necessary repairs.
The older gentleman we saw with Fort Gillen, he always wears a bow tie, always. His firm was the lead architect. They knew there were problems with the building. He went out and he retained, this company was called CT Mail. They specialize in 3D renderings. They come up, they set up, and they take 3D modeling of the entire structure. He then takes that information and Fort Gillen hires or retains a structural engineer. The two collaboration look at what the problems are, where the weak spots are, and start to come up with a plan. As the contractor, we get it after all the plans been put together. They're pretty much telling us on the drawings, this is a public bid project, everything's going to be down in writing before we even look at it, what the plan is to do the restoration. And they give us certain guidelines, we're allowed to offer some input and work through means and methods of how we want to do a lot of the work.
You have to go through a study stage where you produce a booklet of a standard DCAM format, and that booklet then has to be reviewed by everybody and all different levels and funded. So that whole process, that takes at least a year just to get the project defined, scoped they call it, and then budgeted, and then authorized to begin. So yeah, it's probably been 3 years since we started on it.
We're going to remove the, as much as we can on the north facade, because due to the deterioration of the brick and masonry backup wall on that facade, we need to build something that will be a positive anchor and bond the stone back together when we're finished, and that was the cast concrete in the gable portions with positive anchor ties. There appear to be no anchors from the stone to the original brick backup, and there are sections of the brick backup that are still in good shape, but at the two gables they're not.
We went back into that area and did a project very similar to this. Document the existing stones that we could, start to do a dismantle, take down the backup wall, build a newly reinforced structural wall that meets today's code. And then the big thing that ties the new projects and makes them look like the old projects is what happens behind the scenes. It's the mechanical ties. Physically putting steel, metal anchors into the masonry that connect back to a structural wall so that they can't pull away over time. The two are really locked together. We're going to make it look like we never really did work visually from the outside, but it's all going to be up to current code. And that's what kind of makes it a really interesting draw for us.
Finally, in the summer of 2013, with all the necessary approvals and the completion of the bidding process, members of the preservation team began meeting on a weekly basis. The architects, representatives of the state, the Division of Capital Asset Management and Maintenance, the contractor Allegroni, and court and registry officials.
Any other questions on the schedule?
I think part of it we have to replace the surface mounted bolts that go head and bottom.
But that would be the inactive one.
Yeah, on the inactive. I have the full schedule for that door. It came from the company you recommend, Tim Mathers. Send it to me. I'm going over it before I get back to him, and I'll copy you with what we.
It's an active court every day. The second floor is the Berkshire County Registry of Deeds. We have over 100 people coming in and out of the building. We have security in the building. It's a very, very active site. And this building is not going to be shut down for one day during the entire project, which takes a lot more of planning and kind of perseverance of dealing with everyone who has to come in here and working with them to make it a safe work environment for everybody.
We, try to help them out and make sure that they can get what work they have to get done while we are still in fully operational, because it was really imperative that we didn't have to shut down. I think the noise and the dust during the day is probably our biggest challenge.
Use that as much as you can. But once you get past about 10 feet, you can actually see directly into the building. The whole second floor is wide open. That's where 10 feet behind that wall we built another full wall insulated
to keep everybody out, keep the construction out, keep everybody safe inside.
When a certain dollar amount is spent in the process, it triggers certain accessibility requirements. So the expense of redoing the facade caused some accessibility issues, which we know the courthouse didn't have an accessible entrance. It had one in the rear, but that wasn't built to code. And now the code requires 2 accessible entrances, in every building. So.
With the ramps in place, the scaffolding went up, and the first order of business was removing the stained glass window. The large stained glass windows on each of the front gables presented their own set of challenges.
What's going on with the photography is there's a job-specific label that we've made up. And then, this is the east window, that's the west window.
While not overly elaborate, they each had 23 panels set in concrete tracery. Removing the stonework meant removing the glass panels as well and replacing them in precise molds of the tracery. The work commenced with the same kind of written and photographic documentation. These windows had only had temporary fixes to the broken glass since 1876, when the Athenaeum was built. Taping the windows ensured the glass did not fall when the panel was lifted. Once removed, the panels were stored and transferred to David Guarducci's studio in Great Barrington.
And you lay paper over the window, and then you rub it, and it gives you an outline, a tracing outline of the panel. And that's like a map. Afterwards, now you can go ahead and take the window apart, dismantle it, tray it, completely rebuild it on top of one of these drawings.
The rubbing's been taken, and took it apart, and now it's being cleaned, and then it'll get trayed, and it'll get reassembled.
So we'll take apart pairs of a style, and that allows us to stack 2 sections in a tray, sometimes 3 or 4. And then they just go into the trays. The trays are stored here. These windows now are prepped and ready to be rebuilt as David's rebuilding out of the project. So as they're being dismantled, we're replacing the glass that's shattered and broken. And that was where we're using glass from the same era to replace with. And these are clear glass windows, and we tend to keep an eye out on building projects and so on when people just throw it in dumpsters. And we had a house in Great Barrington that was from the late 1800s where the contractor gave us a call and said, we're going to throw all this sash glass in the dumpster, do you want it? One of the things we're trying to do on this window, and what I'm doing right now, is the border glass in the windows, this amber brown border glass, it has metals in it to produce the color. Originally, the glass appears to be a sort of light tan, grayish tan. It's actually originally was an amber glass. And you can see where the glass edge, I don't know if it'll show up for you. It does when you put it against white paper. You can see around the border of the outer edges where all that glass was underneath came and not exposed to ultraviolet light. That's the original color of the glass. But UV light and time has changed the color to this brownish tone. There's no color, nobody's manufacturing that color. We're also trying to replicate it in the studio because we found we get a color that's close, but is much browner, much redder. And we're finding that we're working with an amber enamel on it. And we're trying to get the balance right, but when it's very thin coat of the amber enamel, it matches the discoloration of the original glass. So we're going through this stage to try and get the density correct and firing it in the kiln. And if we can produce it ourselves, because there's not, you know, a horrendous amount of border breakage, then we'll be able to replace missing and shattered border glass that we match the color here. And David is now reassembling a window on the working drawing. So he'll set up ledgers and begin to rebuild this panel on this drawing. But you can see basically how that applies and how he'll basically, you want the cames, assuming the panel that came in wasn't badly distorted or had fallen apart, this drawing should be your true guide. You shouldn't vary from that. You shouldn't get larger or smaller than the lines as they're indicated.
Yeah, these are called the lead cames.
Okay.
I mean, they have two dome side, and these are called semi-rounds. Those are all flat leads. They're true H channel.
Okay.
And the difference in fabricating them is whereas these, you lead the windows with a very tight seam, and the very tight seam is then soldered. With a flat leads, you actually lift the top leaf and you press one came into the other, and then you press the leaf on top of the came, then solder that seam. So they're actually a little stronger because of the way the seaming is done. And they're also a little more time consuming from that aspect. So that is the difference between the way those will be fabricated and the way these are fabricated. And there again, it goes back to reproducing what the original studio artists used. So there's actually no choice with what the lead profiles are.
With the removal of the stained glass panels to Guarducci's studio, temporary walls were built on the interior of the old Athenaeum, and work could begin removing the stones.
Our issues were how much of the stone were you going to take down and why, and how are you going to put it back up again, and how do we know that it's being put back where it belongs, and what were we going to do if we broke a bunch of them and we needed to get some replacements. How could we find matching replacements?
So at the very beginning of this project, we had many conversations about how to proceed, and that included how to document what we had on the building and then how to remove the stones. And one of the things that was required was very careful documentation of what we had before we took it apart. So really good photography, a drawing that would carefully number each stone so that we would know where it would have to go back in the wall.
It's really a three-step process. Every piece is numbered we take pictures of the entire structure. On paper, we number every piece. We make a comprehensive list. It all goes in a binder. So you go up and take a photo down, or even come down here and take a photo up. You can kind of see the whole grid's in place. And that's what's going to establish all our benchmarks.
And also the requirement for the contractor to make it clear to us what his process would be for removing those stones. So there were both written submittals and meetings to discuss how those stones would be protected when they would be removed, because you know, they're big heavy stones and some of them were coming from a great height, and we all wanted to feel confident, you know, before any work was done on the building, that the stones were going to be taken care of and there was the least risk of any damage to the stones, to the building, to the site, to the public when that happened. All of those things needed to be taken into account. So we have those meetings, we have those conversations in advance to plan out the actual work.
Every stone is being documented, numbered individually, and located on it. We've set up X and Y graph of where it is in relation to the building. They all get their own individual number, come down, come on the ground. In this case, there's not enough lay-down space around the building. It all goes in a binder. Comes out here in the field, the foreman gets his binder, and he actually writes the number on the face of the stone with chalk. So we're all labeled, numbered, we know that we have numbers for all the stones. When the stone actually comes off the building, we hit the top of the stone with a grinder, have the stone that's going to be buried later, write the number on it in a permanent marker so that that won't weather or wear away. So through those 3 steps, we make sure that every piece has its own number that is properly labeled. And that number also tells us something back in our spreadsheet. We know what pallet it's going on. We give every pallet a number. And then how we ship them across town to a boneyard 5 yards away, or 5 miles away. When we know where we're going to be in an area, I can look at a list and say I need pallets 25, 28, 29, 30, 33. Let's get those here for tomorrow. Someone can go get those, and we know we have the stones we need to lay for the next couple of days. So it's quite the process to do that.
For the roof is temporary. You know, the concern is we're taking off the face of the building. The face of the building is holding some of the roof. So we've taken measures to try and capture any of the load of that roof that was in the face, picking that up within the existing structure by temporary walls, by 2x6s, by some additional steel, and trying to pick up the point load in different locations and transfer that down to sound locations within the building that can handle that load. When the facade is rebuilt, most of the loads will be transferred back to the newly built, you know, structural wall, stone wall.
In a restoration project, no matter how much you study a project in advance, there are always going to be unknowns. And so you have to kind of think on your feet and take care of issues as they develop.
It's quite a ways into the job. We're already working on the 2 ends of the building, the gable ends, but in the middle there's a section where we were supposed to take out only certain ones that were deemed loose and unstructural and needed to be redone.
We had finished the demolition of the east gable and started to get into the center portion of the building, where it was take out a few pieces of the stonework at the capstone at the top of the center wall, and then predominantly do a grout injection in the top half or maybe even 2/3 of that entire center structure. We started to get into some probes after we took the cap down. We started to see the way that the roof was shored to the existing structure, and wanted to kind of explore those types of connections to make sure we had good bearing of the roof on the masonry wall and the backup wall as they sat there. As we worked our way maybe 8 to 10 feet down the building and physically took a stone out, what we got was quite a surprise. We were expecting a 1/8 of an inch to a 1/2 inch void in the backup wall, and what we encountered was a large amount of silt, sand, deteriorated mortar actually flushing out of the hole with a pretty good speed behind it. Really, there's a gravity of 5, 6, 7 feet of just backup wall material just sitting in that void, and it all just started to come out when we removed the stone.
Very exciting moment when the contractor pulled out a stone above that angle up there, maybe 40 feet up on the wall. And when he pulled the stone out, which wasn't a big stone, maybe it was 8 inches by 12 inches by 12 inches deep, he pulled that stone out, and sand just flew out of that hole under pressure and just shocked everyone, exposing quite a void behind it where there was nothing connecting the stones in front, the face stones, with the backup wall behind. We had tested that down below as high as we could get without having to put staging up, maybe 16 feet off the ground, a couple of years ago when we did some testing, and we found out that in that cavity there was mortar, but it was it was damp and it was very soft, like wet beach sand. Not realizing that up above it would no longer be wet, it was dry, and it would just flew right out.
Like, for example, the stone that we took out when we first encountered this different condition in the backup wall, it had been sounded by the masonry specialist, and it sounded like as if there was either a larger void or maybe the mortar in it was dead or just wasn't set well. So we're going to take out this piece and relay it in mortar to just lock that piece in place. And these pieces were kind of intermittent, you know, through the middle band, where you just go take out a piece, make sure everything looked good, and put it back in. After we saw that condition at one piece, we moved about 10 feet down the line, about the same elevation, took out another piece of about, you know, this size, maybe a 2 foot by 1 foot piece, and we saw the same exact thing. The backup wall, or I should say the debris in the backup wall, just kind of rolled right out, filled an entire 5-gallon bucket. That eighth of an inch or a half inch void that we're anticipating is actually varied from like 3 inches to 5 inches, and it's a current void. It appears that, you know, the anticipated condition was 2 Ys of brick, 2 common bricks side by side, and then the stone on the exterior. And what we've encountered is the stone that they laid was very irregular in the back. And instead of them, you know, they would face their stone so it looked good on the outside, and on the back, when it had a curve or it had a little bit of a whip to it, they would just lay in the wall and wouldn't make the additional cut to get it nice and square. So they laid a 1 wire brick, and instead of fully laying the 2nd wire brick level, flat, they would sometimes lay it as a shiner, they'd sometimes put it on edge, they'd sometimes throw in clips of bricks or chunks of bricks and just fill it with mortar. And in essence, they were building a solid masonry wall, but what happened was, with decades of water getting in through the top, that layer between the inner wire and the stone, all the mortar just really disintegrated and lost all its strength.
It had dissolved the bricks back to a point only 3/4 of an inch or so of the inside face, which we could see in the attic. So we went up in the attic, it looked like a perfect brick wall. Had we made a hole in the mortar that went in at least an inch, we would have discovered that that's how much mortar there was.
The initial plan, in addition to doing the grout injection and getting grout in the wall to better make the inner wire brick and the stone bond together, was also this system of drilling holes and putting stainless steel anchors that go into the stone and then get into the backup wall and are fixed with epoxy to better stabilize the upper center, so then we could actually needle and shore hold that stone in place and do some of the stone removal and replacement below it. And that would allow us to keep going down. We'd actually rebuild a part of that center and then work our way over to the west gable. That system really only works if there's 2 solid Ys of brick. If we were to drill through a stone and get into 1 wire brick, and you're doing a pretty decent size hole and you have a pretty good size tool in your hand, you could actually just push out that single wire brick. It wouldn't withstand the force of screwing into it, plus you wouldn't be getting much of a bite on the inside. So that detail really proved that it really wouldn't work in this type of application. Construction halted. We had demoed the east, we had worked our way towards the center, and the intent was to actually stabilize the center before we did any more demolition of the west or anywhere else. And what we found, you know, now that we're doing the renovation and most of the work's coming back to a current structural code, you know, there's a lot of work from really the team, you know, DCAM, the structural engineer, lead architect, Allegroni, everyone's involved with coming up with plans or sketches and schematics on how do we make this existing system better and how do we get it to meet current code. So we actually did about probably 2 weeks of just exploratory on the building. We opened up plaster walls, we actually dug down at the footings in the basement and started to better understand the actual structural system that is in place.
Then there was a great debate as to whether or not we should leave the backup wall and the voids and fill them with some kind of a glue-like substance that would inject it in there, fill everything up and glue it all and hold it all together, or whether we should just take the brick wall down and replace it with a reinforced concrete wall.
And we're putting together a system that can better support the existing roof. And we really need to stabilize the center portion of the structure of the entire building, really, from the inside with steel before we continue to do masonry demolition.
It was decided after that to remove all the stones on the north elevation rather than just the ones that we had identified.
Had to build another full skeleton of steel from the basement all the way to the roof to hold the whole structure in place since we took off the face. You know, essentially from corner to corner on the north, we took the face down and we took the backup wall down. So we have steel holding the whole thing in place right now. And then we'll come up and there'll be a combination of steel and masonry at the end.
So that meant the entire brick wall had to be removed and it was replaced with an 8-inch reinforced concrete wall. They were making a new backup wall to replace the brick wall.
One of the really helpful things in terms of taking all of the stones down, putting them back again on a new backup, was it gave us the ability to design a whole new system of controlling the water.
The existing capstones, when they go in, there's going to be a better flashing detail on the backside, and they call it a through wall system, where that metal will be carried underneath the entire capstone. So any waters in the backside can't get down into the wall cavity. But even with that new system, they use mechanical pins in that as well. So that the through wall flashing that goes underneath the stone, there's pins that are soldered directly to that flashing that come up, and the stone will rest on top of those pins.
So we had many conversations up on the scaffold. Is this flashing piece of metal flashing going to work just the way we thought it would? Do we need to tweak that design in some way to make sure that we're getting that water to flow away from the building and we're anchoring the stones properly with that, sort of modified design work? And that happened on an ongoing basis as the stones were going back into the wall.
I think generally we have a considerable height on the flashing to make sure that you're not getting capillary action, you're not getting things are collecting down the way they need to.
So for everything from up at the roof level, where there were new flashings put in, to concealed flashings, which you can't see at this point, that were actually built in to keep the water away from these face stones, so that there is flashing that goes up the backup stone and then underneath these face stones, and then with both that metal flashing and then weeps, which are actually tubes that have holes in them that are placed periodically along these joints. You can see one of them here. So that any water that does get back in behind these face stones will have a path to exit outward.
In this way, the new flashing system was installed as the stones were relayed.
But every stone is going to go back in the same place. The historical preservation architectural firm called BCA out of New York City we're working with is really stressing that we introduce almost no new stone.
One of the processes that we go through, working with our client, working with the architect, is to decide what repairs will be implemented. And whether we are going to do those repairs using a new piece of stone that matches the existing stone, or whether we're going to use a kind of mortar, a cementitious patching material that will then match the two different kinds of stone as closely as possible. The preference for larger repairs is always to use real stone because it is more durable, it will wear the same as the mother stone around it. But there are smaller areas where it sometimes makes sense to use patches as well.
And we actually got 2 full pallets of decent stone just from the backup wall. In that void between the outer and the inner, you get chunks of this gray granite. We save it, it's like gold.
We all leaned towards preserving as much as we could of stones. So if we had cracks, we were going in and we were using more of an epoxy stainless steel repair system to pin the existing stones back together.
We cut part of the stone away, trying to blend it in close, and then, like you say, trying to get a color match for an approval to go for it.
Some Dutchmen were used, which is where we have just the face of a similar stone. And in this instance, we're able to take Dutchmen from the back of some of the stones on the building, turn that, clean up the face and make it look with the same finish as the existing, and then epoxy set that in the front to eliminate any areas that there were cracks or delamination. At the end of the day, it was probably over 10% of the job. We repaired probably over 200 stones, both through epoxy injection, and we did some actual just superficial fixes to the exterior where it looked like some of the face was missing and we needed to kind of build that back up a little bit. A lot of challenges, logistics in getting these stones to their exact final place. The stones that we touched on average were 50 to 80 pounds, which we could manage with our own lull and move with some regular equipment. There was a lot of nuances to putting it back together. Not only do we take off every stone and put it back in the same location, but that stone had actually all crept forward away from the building. So in essence, we had to push it all back in plane. So what happened was the tightness of the joints, where it's been sitting for the last couple of decades, is different from where we had to reset it to get it all true and plumb, to more current practice construction, practices. So and with the introduction of rebar in the back, we ran into some instances where we would set the stone, but the back of the stone was now too close or abutting the rebar. So we'd have to take that stone, dry fit it, see how it fit, take it off, maybe take a little bit off the back of the stone if we needed to in certain places, so that we could get it to work with the anchoring that was necessary to hold it in place. So minor modifications were made to the stone in the back, and it was a very shale stone. A lot of the face could easily split and delaminate, and it's part of just the natural part of that stone. Every couple of years, every couple of decades, you'll find that there's some of that stone on the ground around the building. It continually delaminates just a little bit, and us trying to get that right fit of what's happened in the past to what's happened with the current and get it all to blend, it was a little bit of a challenge.
But one is this lull here, and all this pile of buckets, 5-gallon buckets, was used this morning to get concrete up the staging, up to about 18 lifts of concrete, about 2 feet high, running the whole width of the building, 80 feet. And they had to have a concrete truck here, put it into barrels, wheelbarrows, which was then scooped into 5-gallon buckets. The buckets were then put on that lull, carried up, and then there would be a team of guys grabbing those buckets off the lull and dumping them into that cavity between the stone and the new backup wall. They had to get the stone up 2 feet or so on the outside. On the backside, they had a plywood wall, and so every day they had to the stone guys had to get the stonework done in the daytime, and then first thing in the morning they'd come and pour it behind the yesterday's work, and then the guys would do the stone for the next day. Oh, that was a trick.
But when we got up to a lot of the larger stones, we were dealing with pieces that weighed 200-300 pounds. So the logistics in setting those a lot of times resulted in us having to use a crane, where we would physically pick it up from the yard, boom over all our scaffold, and then have that crane lower that stone between the scaffold and the building, where we slowly would tether it back into place, and the masons would be there, and we would get it just before its final resting spot, and in some instances set it with the crane.
And with the stones in place, work turned toward the mortar, its color and its texture, that had been under discussion since the very beginning of the project.
I think in the 1970s, when they did a part of the steel repair, they repointed the mortar around the entire building, and they used a red mortar. It was not historic in either really composition or color. So part of this project was to go back to what was originally used when they built the building.
So one of the things that we did was to remove samples of that historic mortar and take them to the lab for analysis so that we could construct a new recipe so that there could be a repointing mortar that not only is appropriate in terms of its properties so that it works well with the masonry that surrounds it, but also would be a historic color.
We found that it was a composition of, it was a Portland, it was a high calcium lime, there was a fine sand, and it was also it was black, it was dark in color. And they had to use some local aggregate to achieve that color. So we sent it off to a couple different places that do historic mortar mixes, and we were able to come up with a company that gave us all of that in one product, in one bag, where we could just add water, which was a big component for the historical Conservation Commission, also the designers. It gave us more of a defined way to come up with a consistent mix. And the mixture of that product was very, very typical of what was used, or consistent with what was used back in the original construction of the building.
At last, all the stonework was back in place and repointing of the mortar complete. Next came the complicated task of fitting new tracery molds for the stained glass windows.
Tracery is the framing of the stained glass windows, and it was severely stressed in places and cracked, due to the roof coming down because the walls were spreading.
Between all the different sections, it might be tough to see from where you're sitting, but there's 1, 2, 3, 4, 5, 6, 7 kind of individual skinny sections about 2 feet wide. Between all of them is a precast system of concrete. So that's being made new. It's going to have the finish of the original, but it's going to have the structural integrity that will the wind load and whatever is necessary for the current building.
In our business, safety trumps historic. It was deemed, with today's engineering, that there was no choice but to replace it all with exactly the same except reinforced and maybe longer pieces, fewer joints to make them safe per today's standards.
They're gonna rebuild, have all of that stonework redone. Not that hard to do because the bulk of them are rectangles, and I could just read in your email in a list of sizes with, say, a plus minus of an 1/8 inch on them. The only ones that get tricky are obviously the top sections where they're, where you'd have to take a template on that. But we could produce a template off of the rubbing.
With the new precast moldings prepared, the painstaking job of placing these heavy stones precisely in the stained glass window openings began. Securing the tracery to the stonework with anchors and metal plates would ensure they would not move and cause the glass to crack or break.
Is it like a 8 step or 16 thickness of the line? Yep.
To me or to you about the concrete?
Oh, to the concrete?
Yeah.
What about this one? That one shows good, doesn't it? No. Same thing?
Once the tracery molds were locked securely in place, the fully repaired stained glass windows were now ready for their final positioning, paying careful attention to any changes in the size of the tracery openings.
Well, then you double back and you take tape measure measurements. When we were removing these, I went through with a map of a schematic. I just print out something like that, and I went after that came out. I went and I measured the stonework. Okay. And then we measured panels, and then we build them. In this instance, the openings that these were set into were loose. They were generous. In a situation like that, we would either make them, we certainly wouldn't want the panels to get any smaller or tighter. If we observe the opportunity to let them get to, we might even make a decision to use a wider profile on the outside to take some of that space.
Once the stained glass windows were installed, there remained a long list of smaller closing out projects, a few of which had important historical implications.
Jobs don't end. It ends with a whimper. Finally, everything's done. And then as it gets really at the close, the end, we say, no, we don't have a meeting. We could do this over the phone.
Such as the ramp on the front of the building, how should the railings look? A lot of discussion of the front door, try to retain historical elements of the door, and they're doing a remarkable job.
The old door swung in. They were 4 foot by 8 foot, almost 3 inches thick. Huge doors, and they swung in, and they couldn't swing out because there's a stone ornament at the corner of the door. which looks very nice on the outside, but it meant you couldn't swing a door out. So we saw a very similar design on this church done by the same architect in Springfield. They had successfully reconfigured the doors to cut around the stone to open out. So we said, okay, let's do that. Once we found that we could change these doors, we had them completely taken apart and reassembled, and put this different shape on the edge, and they're being put back.
At the same time, restoration was completed in the front lobby.
Wood veneer in place. So this was something that was put in the last couple of decades to just cover up what used to be here. They didn't go over what was there. They actually took out what was there.
And as the Massachusetts Historical Commission requested, murals were put in place on the second floor, showing the Athenaeum in 1876 and in 2013 before this restoration started. All that was left was archiving the plans and any materials left over.
So this box contains all of the stained glass pieces from the original structure that were broken. And all these pieces were replicated. And as part of the historical process, all of the broken pieces have been numbered, identified, wrapped up, and preserved in this box. And then we also have drawings which lay out each one of the window bases and where all these pieces were rubbed. And this is the key for all the different pieces and where they came off from. So this can be historically preserved for record sakes. It's pretty neat.
As the work wound down came a period of reflection to draw lessons on the building, the project, and on the value of historic buildings to communities.
State has taught me is that they have the money and the need to invest money in testing and exploration before the preservation drawings are done. And we had the experts test those stones. We even had a couple of stones taken out, but they were taken out 16 feet above the ground, not 40 feet up, and that condition wasn't there. So we didn't find that out. But that's the nature of things that the state was willing to do. Dig holes down, see where the footing is, make a hole for the wall, as we did, and really what is its construction. We made a big hole in the ceiling in one of the wings there to see what the roof construction was. And, so testing and a little destructive look-sees, terrific, and most places don't have the foresight to do that, and as a result, when they get going, there are a lot more unexpected things happen.
I think one of the important lessons we can take away from this building is the importance of doing a lot of investigation up front. You know, this project was very complex. It took a great deal of resources to put together, and you don't want to make a decision like that lightly. You want to make sure that you're going into it with confidence, that you really studied all of the options of what could or couldn't work for a building, and when you make the decision to do something as extreme as this, of take down an entire facade and put it back, that you've made the right decision. And it was worth doing that amount of testing and taking the time up front, which we did. It took a good bit of time to figure it out, but it's worth doing because then you're going into the project with so much confidence that you've done the right thing for the building.
This was a great project. This was complicated, this was unique, required a lot of planning and a lot of coordination from a lot of different people and a lot of different trades. It was nice to see it all come together. We were able to get the facade up before the winter, and now coming back and doing the type of repairs that we can finish up in the spring and walk away from this building with a really positive feeling that we've done a really long-term fix. And the greatest compliment we get is when people walk by and say, what did you guys do? Because it looks like it's always looked, but looks a little better, and it's structurally sound for a very long time.
To take down the entire front facade of a building while the building is still in use is not typical. to the construction world, to the restoration world. And it required a great deal of coordination and careful study up front to make sure that we were very clear that this was what was needed, and then to make sure that it flowed smoothly through that process.
So then nothing's going to happen to the stone, to the concrete wall. And the stones are held back with not only stainless steel, but it's stainless steel connectors connecting every single stone to a solid new concrete wall.
So it's pretty fantastic that we were able to do this level of work on this facade of the building, and now, you know, we feel confident that it is durable.
And as I look here today at the new work out front and the general attempt overall to maintain all the original masonry and architectural features, that this is a particularly well done project, and it's being kept really in it's the vein it should be kept.
I think the state being very concerned with not only public safety, but also very concerned that they be seen as a positive, good agency that knows how to that will take care of the state's buildings. That was what was driving our managers, and that was very, very nice.
I think overall, historic preservation in any downtown is important, because I think just the reality of preserving that historical fabric, but it's also the quality of the architecture, the quality of the construction. You don't see that as much with modern buildings.
People would point back to, well, we've lost the train station and we've lost the Peace Party House and we don't want to lose any more buildings. But the building was saved, and so the fact that it became part of the court complex was a good thing I think, for Pittsfield, because it helps to retain the historic nature of the Park Square, and the buildings that have been there for a very long time.
That whole section, Park Square, the Berkshire Athenaeum, is a piece of the past that I feel needs to be treasured. That these are beautiful places, and they need to be admired, and they need to be kept sacred.
This building in particular is important to downtown Pittsfield. It is a part of the history of the town, a town that has a great deal of really interesting history. And it's, you know, when people are walking through a downtown, whether they're older people or younger people, it gives you a different sense about your community when you're surrounded by buildings that speak to the history.
You know, I think the city recognizes our history and how it adds to the quality of life here and helps with tourism and moving forward in the development of the city.
It inspired the city and the city's occupants to take stock of their buildings and to start cleaning them and preserving them. And the Athenaeum is sort of at the core of that, because it's one of the most beautiful, it's one of the oldest, and it's part of that restoration of a town's spirit, is to have that building where it is and to look as good as it does.
Our downtowns here in this part of the country really give communities a sense of place and a sense of the history and where their communities came from. And buildings play a very important role in that.
We have to recognize that these are large antiques, and they're disappearing, and we should preserve them. They're our heritage.